We are live. Hi everyone, welcome back to Codera. Today in this video we will discuss the LeetCode daily challenge for 27th of December, that is today, and the problem name is number complement. I'll start with this problem once everyone else joins in. To tell you just a little bit about this problem. This problem is marked as easy and it has a lot of summations. Apart from this problem has been asked in a company, that is Cloudera. So that is also one of the companies that people aspire to work for. Apart from this problem can be done using a lot of variations of the concepts, mathematical concepts or bit concepts. So I'll be telling you about 3 concepts in this problem, and if everyone can hear me and my screen is also visible, so you can consider please giving me a +1 in the chat and like the video as well, so that I can start as soon as possible. Right. So in this problem, that is number complement, you will be given an integer, right? You will be given an integer, and what you will have to do is that integer will have a binary form, right? So what you have to do is in that integer that is having binary form, that can be represented in terms of ones and zeros. You have to flip it, right? Let's say if there is a number, that is 5. So if there is 5, then the binary representation of it is nothing but 101. Now for this 101, what will be the flipping when I do the flipping? So I change this 1 to 0, I change this 0 to 1, I change this 1 to 0. So what is the new number? The new number is 101 in binary form. So let's do it. So this is 1, this is 2, this is 4, right? So that means total this number becomes 2, right? And this is the binary representation of 2. Binary representation of 2 is what? 10, right? Let's say we had another number, let's say 1001. If I have to change this number, so this will become 0, 1, 1 and 0, right? So let's do this: 1, 2, 4 and 8. That means this number is nothing but 6. Earlier this number was what? 1, 2, 4 and 8. Earlier this number was 9, right? So in this way you can see what the actual problem means, that you have to do hi Riya, hi Sethi and hi Tapan. Hi everyone. So right, so in this way, is the problem statement clear to all of you? Just quickly give me a +1 in the chat if the problem statement is clear to everyone, and then I'll consider moving ahead, right? So talking about the first approach for doing this problem, right? Talking about the approach 1, can I say that I can flip the bits, right? I can flip the bits that has been asked to me, right? What I mean by that, let's say I have a number that is 1001, which is what? 1, 2, 4 and 8, that is 9. If I have a number 9, if I have num given to me as 9, okay, right? If I have num given to me as 9, then what I can do is I can have this number and I can flip it. How I can flip it? So what I'll be doing is, if I have to represent this in terms of binary form, so I'll be having a resultant number that I'll be initializing to 0, and what I'll be doing is I'll be having another variable, just flipping, yeah, right? So what I'll be having is I'll be having another variable, let's say p will be initialized to 0, or I can say product, I can say something like a product that will be initialized to 0, right? Not initialized to 0, initialized to 1, right? Because initially you start with 1, right? You move like 1, 2, 4 like this. So this is why, this is what your product will be indicating, right? After that, what I will do is, while my number that I am having, it is greater than 0 or it's not equal to 0, you can say, what I'll be doing is I will check the bit, the current bit. So what is my current bit? My current bit will be nothing but number mod 2. That means 9 mod 2 will give me what? 1. It gives me 1. So that means I am at this digit, right? I am at this digit. So I'll take out this digit and I see that it is 1. So if my bit is 1, then I will do what? Then in my resultant answer, result plus is equal to what? Product into 0, because in that case my bit will not be set. So if it was set, so I'll mark it as 0. Else if it is 1, then what I'll do, I'll say result plus is equal to product asterisk 1, product into 1, right? That means 1, that means if this was 0, so I'll say this is 1 into 2 to the power 1, right? That is how I'll be doing it. And after that, once I'm done with this part, so I'll say product asterisk is equal to 2, that means product will be multiplied by 2. Product each time will be changing, right? 1 2 4 8, like this it would be changing. And my number num divided by num divide is equal to 2, so that means my number will be reduced by 2. So that means if my number was earlier 9, so it will now become divide by 2, that is 4. And if I do 4 mod 2, so I'll get this 0, right? If after that I divide it by 2, so I get 2. So I do mod 2, what will I get? I get 0, right? I get 0. Now I'll divide it by 2, I get 1. So if I mod it by 2, so I get this one, right? So this is how it number will be generating, and in the end I'll be simply returning the result. Let me show you the code part for that particular approach, like what I'll be actually doing. I have the number, I'll make the resultant number, and I'll take it as long or maybe long product, because integer will exceed, right? And what I'll do is, if my number is greater, then I'll check the bit. If the bit is 0, then in that case I'll flip it and make it 1, that is result plus is equal to product asterisk 1. If it's 1, then I'll make it 0, so result plus is equal to product asterisk 0. You don't need to write this else, it depends on you. Then I multiply my product by 2 and divide my number by 2, and after that I return the result, right? This was the first approach. Now coming to the second approach for this problem, what you can do instead is, let's talk about the second approach, right? If the first approach is clear to everyone, then you can consider giving me a quick +1 in the chat, everyone, right? After that, let's talk about the approach 2. Approach 2 is such that what I want, let's say I have a number that is let's say I have a number that is 101, right? If I have this number that is 5, my num is equal to what? Num is equal to 5, and its binary representation is 101. So what will be the, if I flip these bits, so the number will look like this, right? 0 1 and 0, right? So that means this number will be nothing but 2. But how do I actually get it, right? So if you see this and this number, then what will happen in this case, if up till here, what is the maximum set bit? Can I say that the maximum set bit is nothing but this? So what I can do is, I have this number and I can generate a number such that its all bits are set up till here, right? This is the maximum set bit for this number, so I have set this bit 1 and all the other bits towards the right as 1 as well, right? After that, what I have done is, if I subtract this, so what do I get? I get 0 1 and 0. What is the representation for this? The representation for this is nothing but 2. Now you will not understand it, but let me give you another example. Let's say you have 101, right? That is 1 2 4 and 8. That means if you have num is equal to 9, then what you do is, you have the maximum set bit as this, right? So what you do is, you find a number which we generate a number which can reach till here, right? All these bits are set in it, right? So that means 1 1 1 and 1, right? You can make a numbers like that. That means the number would be what? The number would be 1 2 4 8, right? So that means 12 and then 13 14 15, right? The number would be 15, right? Now I have this 1001. I subtract these two, right? What do I get? 0 1 1 0. What is the answer that I'm getting? What should be the answer that I should be getting? I should be getting 0 1 1 and 0, and that is what I'm getting by subtracting it as well. So can you see that I'm getting this, right? So in this way, what will happen is, if I have a particular number, then what I can do is, in my temp, I can first of all push this number. After that, what I can do is, while my number is greater than 0, that is if the number is existing, then what I will do is, I will multiply my temp plus is equal to product, right? Temp plus is equal to product will be initialized to 1. Then I'll keep on updating my product asterisk is equal to 2, and after that, once I'm done with this, so that means what I'm trying to do basically is not this thing, right? What I'm trying to do is, like, my temp will be initially 0, or like you can say temp will be initially 0, right? Temp will be initially 0, and my temp should be lesser than the number that has been given to me, right? And once I'm done with this, so I will say temp minus num will be my answer, right? For 5 you can try. So 1001, let's say if you have been given num is equal to 4, right? If you have num is equal to 4, in that case what will happen? You will iterate. First of all, you will make your answer as 1, right? Your answer will be 1. Then you have the second bit, right? So you will set your second bit as well, right? So you will set your second bit, so that means this bit. So what will happen? Your answer will become your temp variable will become 3, right? After that you will set this bit as well, so that means your answer will become 7. Now you do 7 minus 4, what do you get? You get 3. And if you reverse this, that is 1 0 0, so this is nothing but 0 1 1, and that is the representation of 3. So in this way you do temp minus num and you will get the answer. That is, you iterate until your temp is less than n, and you keep on adding whatever values, you keep on setting them, and then you get the answer, right? The second approach must be clear to everyone. Let me show you the code part for the approach number 2. So for this approach, what I am basically doing is I am initializing my temp to 0 and product to 0 as well, right? And you can say, you can use power function also, or you can say product asterisk is equal to 2, both will work the same. So if my temp is lesser than the number that I am having, so temp plus is equal to power of 2 comma p, that is I am setting the ith bit for it, and then I am increasing, I am moving to the next bit, right? And in the end I am just returning temp minus num, right? In this way I'll be able to get the flipped number, right? The complement of this number, right? In this way I'll be getting, right? So is this much approach clear to everyone? Now there will be a third approach that I'll be talking about. So now there is another approach for this that will be based on bits, right? That will be based on bits. So in that, what I'll be basically doing is, right, let me write it. So now we will talk about approach number 3. Complexity is same for both. Yes, it is same, right? It's almost the number of bits, right? So approach number 3 will be using XOR. So there is a property of XOR. That if let's suppose the bit is 1 and you XOR it with 1, so what does it become? It becomes 0. And if a bit is 0 and you XOR it with 1, so it becomes 1. So if you XOR any bit with 1, it gets flipped, right? It gets flipped. That is the concept that is lying behind. If you XOR any particular bit with 1, it gets flipped. This is the property. Like you can see, 1 XOR 1 gives me a 0. 0 XOR 1 gives me a 1, right? In this way, if you XOR any number with 1, any bit with 1, it just flips, right? So how can we use this approach to our advantage? What I'll be doing for that is, can I say that what I can do is, let's say if I have a number, let's say 1 0 0 and 1, right? So what I can do is, if I have to flip all the bits, can I say that I have to XOR this, right? I have to XOR this, so I have to take another number that is having all these bits as set, that is that this bit should be 1, this bit should be 1 1 1, so that all the bits get flipped, right? If I XOR 1 1 1 1 1, right, if I XOR it with this number, that is 1 0 0 1, so what will I get? I get this, from this I get 0, from this I get 1, from this I get 1, from this I get 0. Can I say that with respect to this number, if this was the binary representation of num, then this is the flipped answer, right? This is the expected flipped answer that I was expecting, and what I have done for that, I have XORed it with 1 1 1 1 and 1, right? So how do I get this, right? Is this approach clear to everyone? If this approach is clear, please quickly give me a +1 in the chat, and then I'll be explaining further. Is this approach clear to everyone? Like, why am I doing this? Just let me know a little quick. Is this approach clear to everyone? Like, why am I doing this, right? Also like the video if you haven't done that, right? So if I XOR it, like if I have this bit, if I have this representation of binary number, then I can XOR it with 1, every bit with 1, right? I XOR it, and what do I get? I get 0, I get 1 1 and 0. So you can see this was the original binary representation, and this is the flipped. So this is actually the complement that we were looking for, right? In this way we have got it. Now how do you get this, right? So let's suppose that you get a number. Let's suppose you are getting some numbers, right? Let's suppose how do you actually get it, right? So can I say that if the number is something like 10 to the power 3, so if I take the log of it, what is the complexity of XOR operator? It is faster than the modulus operator and things like that. It is very fast. It is very close to the compiler, so that is why it is very fast, right? If I have a number that is something like 10 to the power 3, so that means 1 0 0 and 0, right? If this is the number, so what if I find the length of this number? Right? If I find the length of this number, right? If I find the length of this number, what will I get? If I find the length, so it will be nothing but 4. How? If I take the log to the base 10, right, and this is 10 to the power 3, and I do the floor of it, and I add it with 1. So what do I get? I get 3 from here because 3 zeros were there, plus 1, that is nothing but 4, right? 4 digits are set. So if I do 2 to the power 4, what will I get? So that is nothing but 16. Let's write the representation of 16. That is nothing but 0 0 0, that is 1 2 4 8, right? 1 0 0 0, right? This will be the binary representation of the number, right? So 16 will look like this, 2 to the power 4. Why 2 to the power 4? Because this is the length of the number, right? This is the length, and I do 2 to the power length, right? I do 2 to the power length of the numbers, that is nothing but 2 to the power 4. That gives me 1 0 0 and 0, right? If I subtract this number by 1, if I have, let's suppose I have this number, right? If I subtract this number by 1, notice this is a number, right? And if I subtract it by 1, then what will be the binary representation of this number? The binary representation of this number will be 1 1 1 and 1. Okay, this will be it. How? If you have to the power 4 16, if you subtract 1 from 16, right? This is the binary representation of it, right? So this number is nothing but 16. If you do 16 minus 1, you get a 15, and that is what you will get from here as well, like 1 2 4 and 8. That means 8 plus 4 12, 12 plus 2 14, and 14 plus 1 15, right? So this is nothing but 15. So if I subtract from 2 to the power length, I do a minus 1, then I'll get what? I'll get the number which is having all the bits as set compared to this number, right? Right? So in this way, what I can do is I have this and I have this, so I simply XOR them up, right? I XOR them out. So what do I get? I get this number, right? And this is the flipped bit that should have been the answer, right? So 1 2 and 4, this is nothing but 9. So my answer is 9, right? In this way, I'm able to get the answers for every possible number. For every possible number, I am getting the answers, right? It must be clear to all of you. Let me show you the code part for it so that we can discuss about it a little bit more, right? What I'll be doing is, first of all, I'll be finding the length. The length is nothing but floor of log 2 n number plus 1. That is here I have to take floor of log 2. Why? Because I am taking binary numbers, right? So that is why, since I have to find the length of the binary, so that is why log 2 will give me the number of bits, right? And I add it to 1, that will give me the length of the number that I want, right? After that, I do nothing but 2 to the power. This is nothing but 2 to the power length, right? And I subtract it with 1, so I get the mask. And simply, I told you I'll be XORing, so this mask is nothing but all the bits are 1 compared to this particular number, and I do num XOR mask, and I'll get the final answer, right? Is this much part clear to everyone? For this program, the answer will be the length of the number, right? The length of the actual number that has been given to me, that will be the answer, right? So I hope that this problem is also clear to everyone, and this problem was asked in a company like Cloudera. So we have discussed 3 approaches for this problem. And you can find code for all the approaches in the description of this video, right? And if you have liked the video, so please consider giving me a +1 in the chat. And also I'll also be adding the timestamps to this video after this session, so you can also check them out. And I have all the accepted codes for the 3 approaches. I have given them in the description of this video, so in case if you want to look at those codes, so you can do that as well. This problem is for beginners. This is a very good problem. The reason for that is because this problem will help you understand bits more better, right? So that is it for today from my side. In case if anyone has doubt with this problem, so you can comment that down, and I'll be looking into your doubt. All apart from this, if anyone is liking the channel and the content, so you can consider liking the channel and subscribing the channel and liking the video as well. So that's it from my side for today, and thanks a lot everyone for watching, and I'll see you soon in the next one.